Assalamu alaikum dear, welcome to our channel Civil Technology 106. Today we are talking about deflection and beam. Deflection is the difference between after and before the load. There may be set load of the beam, and there may be also the external load. We have a section 8 cm wide and 12 cm depth. Now we have to determine the deflection and beam. This is the section of beam. Yes. Full span of the beam is 7 cm, and this is cantilever beam. One side is fixed and other side is free. We have 2 kilonewton load. The load is of course point load. There are 3 kind of load we use. It means 3 kind of load is most usable load. One is point load, second one is UDL, uniform distributed load, and third one is a uniform varying load. But this is a point load. We have 2 kilonewton. The distance from the fixed end and to point is 5 meter, and other load is other distance is 2 meter. Span is 5 plus 2. The span of the beam is equal to 7 meter. Given data: breadth of the beam is equal to 8 centimeter. The breadth of the beam which is 8 centimeter in centimeter, we have to convert it into meter. So 0.08 meter. This is the breadth of beam. And second is the depth of the beam. Depth of the beam is equal to 12 centimeter. We have to convert it into meter. So 0.12 meter. Total span of the beam is equal to 7. Span we represent by I, so I is equal to 7 meter. Span up to load is equal to L1, which is of course 5 meter. Yes, this is L1, which is 5 meter. Maximum deflection at free end. Now we will determine it. This is our approach to determine the value of y. Deflection we represent by y. Now we will find the value of y. For the determination of y, first of all we have to find some data. This is a modulus of elasticity. Modulus of elasticity is also called coefficient of elasticity. Modulus of elasticity we represent by E. So E is equal to 200 multiplied 10 raised to the power 6 kilonewton per meter square. Yes. Breadth of the beam is 0.08 meter, and length of the beam is equal to 7 centimeter. I mean full span of the beam. And modulus of elasticity we represent by E, which is 200 multiplied 10 raised to the power 6 kilonewton per meter square. And depth of the beam is equal to 0.12 meter. And L1 means the distance from L1 is the distance from the fixed end of this beam to load, which is of course 5 meter. Now we will determine the value of y. Solution. First of all, we will find moment of inertia. For determination of the moment of inertia, we have a formula: BD cube divided by 12. B is the breadth of the beam, which is 0.08. Yes, it is. And D is the depth of the beam, which is 0.12 meter. Cube divided by 12. When we do some maths, we will get 11.52 multiplied 10 raised to the power minus 6 meter power. This is a formula for the deflection of for the determination of deflection of beam. This is the most powerful formula used for the value of y, to determine the value of y. So now we have ready to put the value in this formula to calculate the value of y. Formula is at W divided by EL multiply L1 cube divided by 3 plus L1 square divided by 2 multiply L1 minus L1. W is load, point load on the beam, which is 2 kilonewton. Yes, it is. And E is the modulus of elasticity, which is 200 multiplied 10 raised to the power 6. It is the moment. Yes, it is the moment of inertia I. Moment of inertia we will represent by I. Value of moment of inertia is that we will determine a few minutes ago, which is 11.52 multiplied 10 raised to the power minus 6, and multiply L1 cube. L1, which we have 5 meter, divided by 3 plus L1 square. L1 we have 5 square divided by 2 multiply 7 minus 5 is equal to, when we do some math further, we will get the value of y, which is of course 0.0578. Yes, it is our approach. We done it. This is in meter, we have to convert into centimeter. So the value of y we will multiply with 100, we will get 5.78 centimeter. Yes, it is. Thank you guys, thanks for watching. Subscribe our channel for more videos, and wassalam.